Okay, so we're going to go through the higher maths paper from 2016. Right, so we're starting with quite a they're easing you in this one. So question 1 is find the equation of a line passing through the point minus 2, 3, which is parallel to the line with the equation y plus 4x equals 7. Okay, so to be able to find the gradient of something, we need to have it in the form y equals mx plus c. So we have y plus 4x equals 7, so we need to rearrange that so we have y equals negative 4x plus 7. So therefore our gradient m is equal to minus 4. So we use the equation y minus b equals mx minus a, which we learnt at National 5. So this is our a and that's our b. So we get y minus 3 is equal to minus 4 times x minus minus 2. Okay, so we sort this out by multiplying out, so we get y minus 3 equals minus 4x. That becomes a plus 2, so minus 4 times plus 2 is minus 8. So we're going to get y equals minus 4x plus 3 to both sides, so we get minus 5. Okay, so the 2 marks for this question come for knowing that m is minus 4 and for stating the equation of the line. For just a wee comment in the notes for the marking for this question, it says that for 2016 you would get the second mark there. However, for future years you wouldn't, so that means that you guys need to rearrange it further. Okay, so on to question 2. Right, so we have y equals 12x cubed plus 8 root x, and we have to find dy by dx. So first thing we need to do is always to make our function so that it's in differentiable form. So that means no square roots, so we need to change that square root into being the power of a half. Okay, so we should know that the square root of x is a half, but the way we think of that, that's a square, that's a 1. It's our third laws from National 5. The power goes on the top, the root goes on the bottom to give you your fraction. So then dy by dx, to differentiate, what we do is we multiply by the power. So that is going to give us 36. 3 times 12 is 36, x, and then we take 1 away from the power, giving us 2. And then for our second term, we multiply through by the current power, so 8 times a half, which is 4. And then you've got take away 1 from a half, which gives you minus a half. Okay, so the points marks for this are for getting it into differentiable form. 1 for differentiating the first term correctly, and 1 for differentiating the second term correctly. On to question 3. Right, okay, so we have here a recurrent relation where un plus 1 equals 1/3 un plus 10, and we've been told what u3 is, and we want to find u4. So u4 is going to be equal to 1/3 u3 plus 10. So that's 1/3 times 6 plus 10. So that is 2 plus 10, which is 12. So u4 is 12. Okay, so explain why the sequence has a limit. Okay, so the sequence has a limit as that a is between 1 and minus 1, okay, where in this case a is 1/3. Okay, and it's also because it's linear. Okay, so the sequence has a limit as that number multiplying the un is between 1 and minus 1. Right, so calculating this limit that we've been asked. Okay, so we need to know the equation for the limit. So the equation for the limit is that L is equal to B over 1 minus A. So that is 10 over 1 minus a third. So that is going to be 10 over 2/3. Okay, I'm going to keep going over to the side. So that's 10 times by 3 over 2, which is 15. Right, so the marks for this question are, you just get 1 mark for getting 12 there, 1 mark for stating that you know that the limit is that, but if you're writing it this way, you need to expressly state that A is 1/3. So you need to show them that you know what A is, or you can just write -1 and then put the third in there. That's also acceptable. Okay, so question C, part C, you get a mark for substituting into correcting the limit and 1 for calculating the limit. Okay, so on to question 4. Right, so we have to find the equation of the circle in this question. We've been given the points A and B, where A is -7, 3 and B is 1, 5. Okay, so first thing we need to do for the equation of a circle is we need our radius and we need our centre. Okay, so first thing will be to find the centre. So we have the points A and B. So we've got -7, 3, and we've got 1, 5. So we want to find what is halfway in the middle. So if we kind of think about this, I do this quite visually. Some of you will have been taught to do this a lot more by equations, but I find that doing it visually helps me. Right, so in our x direction, our change has gone from -7 to 1, so that's 8. And our y has gone up 2. So to go halfway, it would be 4 and 1. So to our first coordinate, so to coordinate A, so the centre is going to be -7 plus 4, so -3, and 3 plus 1, which is 4. So if you can see, I've kind of stepped out of, because the centre of the circle is always halfway in the middle of the diameter, and we can see that the change is 2 vertically and 8 horizontally, so we can half both of those and add them onto the first coordinate or take them away from the second one. Okay, so that's given us the centre. We need to find the radius. So doing the radius is going to be the distance formula. Okay, so the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to have the square root of, so it's going to be 5, 1 take away so 8 squared plus 2 squared, because we're finding the length of the hypotenuse of the triangle we kind of drew for part 1. Okay, so that's going to be the square root of 64 plus 4. So that is, so we get the square root of 68, and that's the whole diameter of that, so we need to find half of that. Okay, so therefore the radius is equal to the square root of 68 divided by 2. Okay, so here the good thing to do would be to simplify that square root of 68. So if we think about it, 68, so we have 1 times 68 to split it into thirds to try and get something, or it would be 2 and 34, which doesn't help us. 4 and 17, that is going to help us. So that is the square root of 4 times 17, so 2 root 17. Okay, so here the radius is 2 root 17 over 2, which just gives us the square root of 17 as the radius. Okay, so we need to be really comfortable using our thirds and manipulating them how we did at National 5. Okay, so therefore at this point we can do the equation of the circle, which is going to be x plus 3 squared plus y minus 4 squared is equal to 17. Okay, so we have question 5. So we've got to find the integral of 8 cos of 4x plus 1. Okay, so integrate 8 cos 4x plus 1 with respect to x. Okay, so when we are integrating, it's the opposite of differentiation in terms of like the trigonometric functions. So when we differentiate, sine x goes to cos x, which then goes to negative sine x, which then goes to negative cos x. So when we're differentiating, we're going this way, but when we're integrating, we're going back the other way. So when we integrate cos, it becomes sine. So we're going to have 8 sine 4x plus 1. The other thing we need to do is then need to divide by the differential of the bracket, which is 4. And then we need to add our constant. So 8 divided by 4 is 2, so we get 2 sine 4x plus 1 plus c. So for this, our marks are 1 for starting to integrate, so getting the sine part, and 1 for a complete finished integration of 2 sine 4x plus 1 plus c. Okay, so we've got the functions f and g are defined on the set of real numbers. The inverse functions f to the minus 1 and g to the minus 1 both exist. So for part A, we have to, given f of x, we need to find f to the minus 1 of x. So we have f of x is equal to 3x plus 5. So to find the inverse, we let y equal f of x. So therefore y equals 3x plus 5. And we're going to rearrange so that we get x, which is going to give us our f to the minus 1 of x. So we get y minus 5 equals 3x, because we take away 5 from both sides. We divide both sides by 3. So we get x equals y minus 5 over 3. So then we can replace our f to the minus 1 of x. So f to the minus 1 of x is equal to x minus 5 over 3. So what we're doing here when we're finding the inverse is we're finding the reflection in the line y equals x, and to do this we rearrange the equation. Okay, so for part B, if g of 2 equals 7, write down the value of g to the minus 1 of 7. Okay, and this is just knowing how this works, which is that it gives you back what you started with if you do the inverse. So therefore, g to the minus 1 of 7 has to be 2. Okay, so the marks for this question, you get 1 for getting to the step y minus 5 equals 3x, 1 for getting x equals y minus 5 over 3, and then the last one for rewriting it as the inverse function of x equals x minus 5 over 3. And then you get 1 mark for the 2 in part B. So on to question 7. Right, so question 7 we have vectors. We've got 3 vectors, can be expressed as follows. We've got the vector fg, we've got the vector gh, and the vector eh. So part A, we've been asked to find fh. Okay, so f to h, well, that's saying we're going to start at f and end up at h. So we've got to start with the vector that starts at f. So we go from f to g, and then we're going to have to go from g to h. So we add those together. So we've got, when we're doing this, we can either leave it as unit vectors or kind of change it into column vectors and then change it back into unit vectors at the end. So I tend to put it this way and then change it back at the end. So remembering that our I, j, and k are just kind of the same as our x, y, and z's. They're just kind of components of those. So we get minus 2 plus 3, which is 1, minus 6 plus 9, which is 3, 3 plus minus 7, which is minus 4. So that is equal to I plus 3j minus 4k. Right, so for part B, hence otherwise, find f e. So to go from f to e, we're going to have to go from f to h, and then subtract e to h. Because when we subtract, it's the same as adding the opposite when it comes to vectors. Okay, so again, write these as column vectors generally to make them a little bit easier. Take away EH, which is 2, 3, 1. So we get 1 take away 2, minus 1, 3 take away 3, which is 0. And we've got minus 4 take away 1, so we have minus 5. So therefore it is equal to minus I minus 0j and then minus 5k. So our marks for this, we get 1 for knowing that we need to add there and 1 for our answer, 1 here for knowing we need to subtract, and 1 for our answer. So on to question 8. Okay, so we need to show that the line with equation y equals 3x minus 5 is a tangent to the circle with equation x squared plus y squared plus 2x minus 4y minus 5 equals 0, and find the coordinate of the point of contact. So the first thing to do is to substitute in your first equation into here, so into your second one. So we're going to get x squared plus 3x minus 5 squared plus 2x minus 4 times 3x minus 5 minus 5 equals 0. Right, so when we work through sorting this out, we get x squared plus 9x squared minus 30x plus 25. If you need help on doing squaring brackets that quickly, I have videos on it in expressions and formula. Plus 2x minus 12x plus 20 minus 5 equals 0. So when we sort all this out, we're going to get 10x squared minus 30 plus 2 minus 12, so that's minus 40x. And then we've got 45 take away 5, which is minus 40 equals 0. Not minus 40, plus 40. Okay, so then we, from here, can take out a common factor of 10, so we get 10x squared minus 4x plus 4 equals 0. So from here, for things to be a tangent, then b squared minus 4ac equals 0. So we're going to use this. So our a is 1, our b is minus 4, and our c is plus 4. So we're going to have minus 4 squared minus 4 times 1 times 4. So that gives us 16 minus 16, which is equal to 0. So as b squared minus 4ac equals 0, the line is tangent. Okay, and the points where this is going to meet, so we can go back up to our function up here, to our 10x squared minus 4x plus 4. So when we get this, we can factorize the second bit. So I'm going to do this over here. So we're going to get x plus x minus 2 x minus 2 equals 0. So therefore x equals 2. And then when x equals 2, y equals 3 times 2 minus 5, so it's equal to 1. So therefore your point of contact is the point 2, 1. So marks for this question. First one for substituting in your y. Your second mark for using this method would be for getting to this point here, so setting it equal to 0. Third one for correctly substituting into the discriminant. The fourth one for saying as it's equal to 0 the line is tangent, so that whole sentence for that last one. And then your fifth mark is for getting your point of contact to 1. Okay, on to question 9. Okay, so for question 9 we have to find the x-coordinates of the stationary points on the graph with the equation y equals f of x, where f of x equals x cubed plus 3x squared minus 24x. Okay, so first, not even looking at part B yet, we're going to do this. So we have f of x equals x cubed plus 3x squared minus 24x. Okay, and what we want is where f dash of x equals 0, because at the stationary points the gradient is 0, and the gradient is what we get when we differentiate. So f dash of x equals, we bring down the power, which gives us 3, and then we subtract 1 from the power, so we get 3x squared. Bring down the power, 3 times 2 is 6. Subtract 1 from the power gives us just x. And then when we've got a term which is x and the power is just 1, then that becomes 1. So we get 24 times 1, so just 24. Okay, so we set this equal to 0. 0 equals 3x squared plus 6x minus 4. 24. So we can take out a common factor of 3, so we get 3x squared plus 2x minus 8. So then we can do this to give us x at the start of both our brackets, and it's going to be plus 4 and take away 2. Again, if you're still struggling with factorising, go back, look over the National 5 stuff. I might make a video at some point, but I can't guarantee that it's going to be before you have a prelim or before you have an exam, because I'm busy making videos for other things. Okay, so then we get x plus 4 equals 0, x minus 2 equals 0, so we get x equals minus 4, and x equals 2. Right, so for part B, we have been asked to find the range of values for x at which the function is strictly increasing. So for this, there are a bunch of different ways we can do it, but we are going to do this with sketching the graph of the gradient. Okay, so from part A, we know that when we get the gradient is going to be a parabola, and when this gradient is increasing, it's greater than 0. So this parabola is 3x, so we're drawing 3x plus 4, x minus 2. That's what we're drawing. So we're going to have 2, we're going to have minus 4. Because our x squared is positive, we know the shape is going to be a U shape. Okay, so if we kind of sketch this graph of the gradient, we know that the gradient is going to be greater than 0, which means it's going to be increasing. Okay, so the function is increasing when x is less than minus 4 and when x is greater than 2. Other ways you could do this are by drawing a nature table, or by finding it as being greater than, setting your function greater than 0. Right, so on to question 10. Okay, so the marks for this question are, you get 1 mark for knowing to differentiate and getting your first term correctly, 1 for completing your differentiation and setting it equal to 0, 1 for factorising, and then 1 for getting both of your terms for x. Okay, and then the second question, you get 1 mark for using a method to find your values, so your graph, for example, or if you used a nature table, your nature table would get you a mark, and then 1 for explicitly stating what that actually means, and how that gives you the answer. So question 10, the diagram below shows the graph of function f of x equals log to the base 4 of x, where x is greater than 0. The inverse function exists on the diagram. In your answer booklet, sketch the graph of the inverse function. So I've got the inverse function here. I've got that graph on the corner of the page. So inverse functions, this bit isn't something you need to draw, but it's just a little bit of explanation for you if you're struggling with these, are a function that is reflected in the line y equals x. So what happens with these is the x coordinates become the y coordinates of the inverse, and the y coordinates become the x. So we're going to have a point here, which is going to be 0, 1, because what we've done is we've flipped around the coordinates, and then we're going to flip around the coordinates on the one, which is going to give us 1, 4. So make sure that your 1 is in line with that 1, because we already have a 1. So we're going to have the line 1, 4. And then drawing these so that it's reflected, we end up with, so it's symmetrical about that point, we end up with this graph looking something like that. Okay, so your marks for this are 1 for having the graph reflected, so like the kind of shape of it, and the other for having reflected the points or correctly annotated those points. Okay, so on to question 11. Okay, so question 11, we have A and C are the points 1, 3, minus 2 and 4, minus 3, 4 respectively. Point B divides AC in the ratio 1 to 2. Find the coordinates of B. So for this, my first comment is always going to be draw a sketch. It's going to help you out. It's going to make you less likely to make a mistake. It doesn't mean you won't, but it might make you less likely to. So we have A and we have C, and it's split in a ratio of 1 to 2, so that's 1 part and that's 2 parts. So we've got 1, 3, minus 2, and 4, minus 3, 4. Okay, so to go from A to C, our x has to change 3. Okay, drawing this as a column vector, not like that, apologies. So 3. Our y goes from 3 to minus 3, so that's take away 6. And our z goes from minus 2 to 4, so that's adding 6. Okay, so all I've done there is gone, like, to get from A to C, what do I need to do? I need to add 3 to my x, I need to take away 6 from my y, and I need to add 6 to my z. So then to go from A to B, it's going to be 1/3 of that distance because we've got 3 parts. So 1/3 of 3 minus 6 and 6, which is going to give us 1 minus 2 and 2. So you need to find the coordinate though. So therefore B is equal to, so we're going to add 1 to our coordinate at A, so that gives us 2. We're going to take away 2 from our y coordinate, which is going to give us 1. And then we're going to add 2 to our z coordinate, which is going to give us 0. Okay, so part B, we have been told that KAC is a vector of magnitude 1, where k is greater than 0, so we need to find the value of k. So the magnitude of KAC equals 1. Okay, so to do this, first we need to find the magnitude of AC to know what that K needs to be to make it 1. So to find the magnitude of AC, that is the square root of 3 squared plus minus 6 squared plus 6 squared, because we're using our values for AC that we found in part A. Okay, so that gives us the square root of 9 plus 36 plus 36, remembering this is the non-calculated paper. So that gives us it as being 36 and 36 is, those are 4, so that's 8 lots of 9, 9 lots of 9, so the square root of 81, which is 9. If you need to do like a chimney sum or something like that, it's not a problem. Okay, so therefore K has to be equal to 1/9 to make that magnitude 1. Okay, so the marks for this question are: you get 1 mark for interpreting the ratio, so for getting a third, and 1 for writing your coordinate at the end as a coordinate. If you write it as a vector, you do not get that mark. It needs to be written as a coordinate, not as a column vector. They're not the same, not even close. Right, so for part B, one of my marks for part B I actually got in part A, which is for finding AC. You get 1 for finding the magnitude of AC, which is 9, and then 1 for knowing that K would be 1/9. Okay, so on to question 12. Okay, so we have to find h of x, and we've got f of x is 2x squared minus 4x plus 5, and g of x is 3 minus x. So we have h of x equals f of g of x, which is equal to f of g of x is 3 minus x. So that's saying that into that function f we're putting 3 minus x. So we're going to get 2 times 3 minus x squared minus 4 times 3 minus x plus 5. So again here squaring brackets, so it's 2 times 9 minus 6x plus x squared minus 12 plus 4x plus 5. So that is going to be 18. Take away 12x plus 2x squared minus 12 plus 4x plus 5. So then when we kind of simplify this and get all our terms in our right orders, we get 2x squared. We've got minus 12 plus 4, which is minus 8x. And we've got 18 minus 12 plus 5, so that's 6 plus 5, which is plus 11. And then we can write QED to show that we have shown what they've asked us to do. Okay, so our second part of this question is to express this in completed the square form. So even if you weren't able to do part A, you might be able to do some of part B. Okay, so we start with 2x squared minus 8x plus 11. So to complete the square, we're kind of looking at the first 2 terms and kind of ignoring the number to start with. So we can take out a common factor of 2 to give us 2x squared minus 4x. And then the plus 11 we kind of leave for now, don't think about it at the moment. So we're looking for what bracket would we need to give us x squared minus 4x. And the bracket we would need would be x minus 2 squared. Because when we multiply that out, we'd get x squared minus 4x plus 4. So because we've got that plus 4, we need to take that 4 away. And then we need to add the 11 on the end as well. Again, if you're not sure on completing the square, there is a video on it in Expressions and Formula. I've went through both National 5 recap and into this, which is a slightly harder version from higher. So we multiply this out, so we get 2 bracket x minus 2 squared minus 8 plus 11 equals 2. X minus 2 squared minus 8 plus 11 is plus 3. Done. Okay, so your marks here are, you're going to get 1 mark for interpreting the notation, so for substituting incorrectly here, and 1 for getting this second last line, which leads you to showing that answer correctly. Okay, for question B, you get 1 for taking that 2 out as a common factor from the first 2 terms, 1 for knowing to complete the square or starting to complete the square, and 1 for your final answer. Right, on to question 13. Okay, so question 13. We have a triangle ABD and it's right angled at B with the angles BAC is P and BAD is Q. And we have to show that the exact value of cos P, Q minus P is 19 root 17 over 85. Right, so my first advice for this is to draw these triangles out separately, because kind of when you have them together, things can get a bit confused. So if you have something like this, I would always first draw them out as 2 separate triangles. Okay, so we know that the bottom of each is 4. This is P, this is Q. Okay, the side of the triangle, this one is ABC. That's 1. And this one is ABD. That side is 3. Okay, so we have to find the third side, the length of them. So this first one, so AC can be equal to the square root of 4 squared plus 1 squared. Okay, so that's the square root of 17. Oh, look, we're getting something that's in our exact value solution, so we know that we're kind of headed in the right direction. And then this one, we should be able to see that it's a 3, 4, 5 Pythagorean triple triangle. If you needed to, you could go AD is equal to the square root of 3 squared plus 4 squared, which would work out as the square root of 9 plus 16, it's the square root of 25, which equals 5, just to show you that that is correct, okay? So then, we take our cos Q minus P and we need to use our expansion. Okay, so that is equal to cos Q cos P plus sine Q sine P. Okay, so over here we can kind of figure out what all these things are. So sine of P, it's opposite over hypotenuse, so that's 1 over the square root of 17. Cos of P is adjacent over hypotenuse, so that's going to be 4 over the square root of 17. And then sine of Q is opposite over hypotenuse, so it's going to be 3/5. And the cos of Q is adjacent over hypotenuse, so that's 4/5. So now we can substitute all of these in. So we're starting with cos of Q, which is 4/5. And we are multiplying that by cos of P, which is 4 over the square root of 17. Okay, so then we've got to add sine of Q, which is 3/5, times by sine of P, which is 1 over the square root of 17. So that gives us 16 over 5 root 17 plus 3 over 5 root 17. Okay, so we're kind of getting there. So that gives us 19 over 5 square root of 17, which you then want to times by the square root of 17 over the square root of 17. So on the top we get 19 root 17. And then on the bottom we're going to get 5 times 17. So 17 times 5. 7 times 5 is 35. 1 times 5 is 5, plus 3 is 8. Because again, this is non-calculator, so you would just be doing that. So you get 19 root 17 over 85, which is the answer we're looking for. Okay, so the marks for this question are, first mark is for getting the lengths of AC and AD, so the two hypotenuse. You get that one. You get 1 for, your second mark was for the expansion correctly. 1 for calculating 2 of sine P, cos P, sine Q and cos Q correctly. So if you get those two correct, you get that third mark, or the other two, it doesn't matter, any combination of them. For your fourth mark, it is for correctly substituting them all into this formula. And the last one is for correctly getting it into the form that is given in the question. Okay, so that's question 13. On to question 14. Right, so question 14 we have logarithms. So for part A we have to evaluate log to the base 5 of 25. Okay, so to do this we need to take that 25 and we should see that that is a power of 5. So we can see that we can rewrite that 25 as 5 squared. And then with our logarithm rules, we know if we have a squared inside our logarithm, we can bring it down to the front. So we get 2 log to the base 5 of 5. And anything to the base of itself is just 1, so 2 times 1, so it is 2. Right, so for part B, we've been asked to hence solve log to the base 4 of x plus log to the base 4 of x minus 6 equals log to the base 5 of 25, where x has to be greater than 6. So, for part B, first things is to write it out, log to the base 4 of x plus log to the base 4 of x minus 6 equals log to the base 5 of 25. So in our next line we can replace that with a 2 over there. When we have logarithms that are added together, we can combine them into 1 to multiply them. So it becomes log to the base 4 of x times by x minus 6. And then here it's another one of our logarithm rules, is that we can change a logarithm into exponential. Okay, so the base of our logarithm becomes the base of our exponential. What we're equal to becomes the power of our exponential, and what's kind of stuck in the logarithm becomes our other bit there. So when we kind of multiply out, so we're going to get x squared minus 6x equals 16. So we have x squared minus 6x minus 16 equals 0. So to solve this, we're going to have to factorize. So we have here, so we're looking for two numbers that multiply to give minus 16, but add to give us minus 6. So it's going to be minus 8 and plus 2. Because minus 8 and plus 2 multiply to give us 16, but then add to give us minus 6. So therefore x equals 8 or x equals minus 2. Okay, so therefore, because we got told in the question x is greater than 6, so as x is greater than 6, x equals 8. Okay, and if you don't have that last little bit, you would lose a mark here. Okay, so the marks for this question, just 1 mark for knowing that it's 2, 1 mark for using the result of A and substituting in, 1 for using your laws of logarithms to combine your first two logs, Your third mark is for using your laws of logarithms to change it to an exponential. Your fourth mark for part B is for setting it equal to 0, so making it a quadratic. And then your last mark is for solving and identifying the appropriate solution. Okay, so it says specifically the appropriate solution. Okay, not that if you've got the -2, that's not going to cut it. You need to say that it's specifically the 8, because it said in the question that x has to be greater than 6. Okay, so on to question 15, which is the last one in this paper. Okay, so last question, question 15, and I think, to be honest, this one's not too bad. So for part A, we have to find the values of A, B, and K. We have a graph, and it gives us that f of x is equal to k, x minus a, x minus b squared. Right, so we need to know what a is equal to, what b is equal to, and these can be read off the graph. K takes a little bit more work. Okay, so if we look at our graph, here the bracket with the squared is our double root, and our double root is the one where it just touches the x-axis and goes back. So b is equal to -5, because in that bracket we would need to have +5, so b would need to be -5 to give us the 5 in the bracket. And a is our single root, so that is going to be 4. Okay, so to work out our k, we're going to have to go y equals k times x minus 4, x plus 5 squared. Okay, and we have the point 1, 9, which we can substitute in. So we're going to get 9 is equal to k times 1 minus 4, 1 plus 5 squared. So 9 is equal to k times -3 times 6 squared, which is 36. Okay, so therefore k is equal to 9 divided by, what is 3 times 36? 36 times 3. So 6 times 3 is 6, 12, 18. 3 times 3 is 9, so we can add that, so we get 108 on the bottom. And we can simplify this because they're both in the 9 times table, so we get 1 and we get 12, and we should have a negative as well, so we get -1/12. Okay, so part B is quite hard to get your kind of head around generally. So for the function g of x equals f of x minus d, where d is positive, determine the range of values for which g of x has exactly one real root. Okay, so if we think, what does that negative do? It says we're moving our graph down. So if we move our graph down just a little bit, I'm going to kind of sketch it on here. So say I moved it down 1. What would happen is that we'd get the point 1, 8, and we would have 3 roots. Okay, we're looking for 1 root, not 3. So we need then for this point here to become under the x-axis. And for that to happen, we need to move it down more than 9. Okay, so then that is telling us that d has to be greater than 9. Because once that one's below there, we're going to have a graph that goes like this, which only has the 1 root. As long as that bit, that maximum is below, that maximum turning point is below that axis, we're going to have only 1 root. Okay, so the marks for this are 1 for 4, 1 for -5, 1 for -12, and then 1 for d has got to be greater than 9. Right, okay, so that's it for the 2016 paper 1. If you've got any questions about it, leave a comment and I can get back to you if anything's unclear or if you're wanting to see another way. If this has been helpful, please like my channel, like the video, or subscribe to my channel. There's a lot of videos on here about higher maths and lots of ways that it can help you. So thank you for watching. I hope that's been helpful. And paper 2 will be coming soon.